So the intended spirit of this talk is just like, what matters right now in interpretability? Just like, what kinds of research I'm excited to see happening right now and why, and what kind of recent papers I've been particularly excited about. Obviously, this is very much my personal opinions and biases, and I'm sure if you ask other interpretability people, they'll have their own takes, but like, all right, maybe I want to begin by just trying to map out roughly the kinds of areas I want to talk about. So maybe a good place to begin is just like, what has changed about AI in the last 12 to 24 months? And brackets, that actually matters. So things that I will call out as I think this is a pretty big deal. Firstly, models are better. Specific things included in this. Models are way, way better at agentic tasks. This gives us a tool to use for Interp. So kind of, I'll put all of this under interpretability agents. Models are scarier. I feel like how to phrase this? It seems much more plausible to me that models have some notion of coherent beliefs or goals, or at least some kind of drives and ability to plan. And this means we have much more interesting things to study, while also being concerning. Yeah, maybe I'll summarize this as we can actually interpret real AGI safety issues. Another massive difference is everyone loves using inference time compute now, in particular reasoning models. So like, historically, you'd put a ridiculous amount of compute into training a model, and then you would only have it produce a fairly small number of tokens. And over time, this is like drifted upwards, and it's got kind of crazy in the last year as companies have gotten better at explicitly training models to do this. And this, reasoning models raise many new challenges for interpretability, and kind of what those are, why you might care about them, why you might be skeptical that they matter, etc. I'll kind of get to later. I think more interesting ones, we're better at making model organisms. So models with particular weird, messy properties. Interpretability is starting to have actual production relevance in the sense of there are things, well, there is a very limited but non-zero set of things where interpretability related to techniques like probes for monitoring and various kinds of interpretability for auditing seem like they either beat baselines or add something not covered by baselines such that they are actually real-world useful. And yeah, I think that I think that these are actually real-world useful. So maybe I'll bucket this as applied interpretability. And so let's see. I feel like I'm probably missing interesting changes in the last year or two. Anyone want to call out things they think might be important changes in AI that should affect what interpretability researchers do? Gerson?
Yeah, maybe this is already covered, but RL.
Sorry, I totally lost the ability to hear you.
Hello?
Oh, I can hear you again. Sorry,
Oh.
am I saying that again?
Yeah, I was saying this might be covered some one of the other points, but like the use of reinforcement learning.
Yep. Yeah, maybe that should be a sub point here. There's kind of the practical problem that people kind of have models generate many more tokens now than they used to, and these kind of build on each other, but also these are like trained with reinforcement learning, and that can create interesting phenomena. Yeah.
Yeah, another one, I guess like the more popular usage of MLEs.
Yep. I think various kind of like architectural changes. I don't know, like multimodal is a bigger deal. MOE is a bigger deal. All kinds of cursed architecture changes. Much longer contexts. By and large, I view these as things that can make some interpretability investigations kind of more annoying, but don't ultimately seem that consequential, especially as at least the part of the field I'm most excited about have kind of drifted away from the let's try to fully reverse engineer the model at the weight level to more like let's try to understand what kind of different checkpoints within the model mean and how information flows around and do things like causal interventions, which is quite a bit more abstracted away from the like precise implementational details. And I don't know, yeah, models. I would say models are bigger, but there's actually a weird thing where model sizes haven't increased that much. I don't really know why. But like, again, if you look at the, I don't know, GPT-3 was like 180 billion parameters, and then Llama 3 was like the biggest open source model for a while, and that was like 400B. And while there are other bigger ones like R1 and Kimi, these are like very sparse, and in terms of actual flops used per token, they're kind of lower than GPT-3. It's not very weird. But I don't know, people train things for longer. All right, so this seems like a pretty good list. Maybe one thing. So let me just briefly switch. Another source of potential inspiration for to talk about in my kind of how to be a Mechanistic researcher post, I have a list of cool things in Interp that I like, which, yeah, kind of different, similar but different question to like how is AI different? But yeah, I think this is basically covered by the list. I think things I might copy from here that weren't already there, and I think kind of fit in would be this and downstream tasks. But all right, so I think the way I want to structure it from here is maybe going to be trying to refactor this into what do I think should be happening in Mechanistic, and kind of talk through a bunch of my favorite examples of work that kind of fits within these and how you might build on it and kind of why I think this work is exciting. And yeah, I think that hopefully this gives something of a picture of what's exciting. So yeah, maybe what do I think should be happening? Kind of a bunch of these just kind of follow from here. So I think that reasoning model interpretability is a pretty different flavor of question from interpreting a single forward path of a model. The field does not really seem to be investigating this that much, and I find this kind of confusing. And I am excited to supervise many of reasoning model interpretability frameworks. I think that a downstream consequence of models kind of becoming scarier is I think that there's just like much more interesting phenomena in these models to study. I'll maybe call this, there's like the broader category, which I kind of think of as AI psychology, or like kind of one way to think about it is like the human brain has the fast intuitive bits and then the like slow reflexive bits. Lots of classic Mech Interp, I think, has been very much studying the fast intuitive bits, like the model's reflexes for indirect object identification or addition or whatever. But I feel like you can kind of reasonably think of modern models as having some kind of more coherent internal processes that are potentially better modeled via some kind of analogy to psychology. All this is complete bullshit. We don't really know, but I think it's sufficiently plausible that I want to call this a real area. One thing within this that I'll call out as particularly exciting is what I'm thinking of as science of misalignment. Kind of, if we think that a model might be misaligned, how do we actually tell? What are the right tests to run? How can we distinguish this, etc.? Another category of thing, just like automating interpretability. We have good agents now. I'm generally very into downstream tasks, but I think I'll highlight one of my favorite kinds, which I think of as auditing games. And yeah, there's maybe another aspect of AI psychology would be debugging model failures. I should probably promote this to a higher level category. Just like, it seems like we kind of ought to be, one of the things that it feels like should be an interpretability review researcher's job is that when a model does some weird shit, even if it's not like misalignment, even if it's, like thinking that 9.8 is less than 9.11, interpretability researchers should just clearly be able to figure out what is happening and why, and advise on how to fix it. It just feels like if we were like a great functioning field who are crushing it, this should be within the kinds of things we're able to do. I think currently this is not a thing that regularly happens, but it might be a thing we're capable of. And this might look like studying psychology, or it might look more like kind of some more deeper circuitry in the model is just like broken or bugged in some ways. I think that, maybe other kind of aspects of AI psychology that I think are important. Lie detection, I think, is just a really important area. If models or kind of eliciting model beliefs / lie detection, just like, do models even have coherent beliefs? How can we elicit them? And evaluation awareness, both detection and suppression. If models know that you are testing them, that kind of breaks all your evaluations. This seems bad. And some other high-level categories I probably want to highlight. I think there's been like a bunch of kind of promising work on influencing fine-tuning, or kind of controlling fine-tuning. Well, let's go with like steering fine-tuning. Just like, we want the model post fine-tuning to have learned certain kinds of circuitry and not others. Obviously, people do this by just like filtering the data in normal ways. Are there ways that interpretability can help make this process better? Can we fine-tune models to have the properties we want and not the properties we don't want? Is a pretty massive chunk of the alignment problem. So this seems like a pretty interesting area if interpretability can help. And maybe zooming out to some of the underlying beliefs here, one take I have that would probably be considered controversial by some is interpretability should focus on understanding things, not controlling things, unless there's a really good reason otherwise, which I guess is kind of downstream of a broader belief of Interp often is not the right tool for the job, and we should focus on use cases where we believe we can beat baselines. And yeah, so the kind of first steps of unpacking what I actually mean by this. I think that if you have a model, there are like two kinds of questions you can try asking about it, or like two kinds of things you might want to do. One of them is to understand the factors that led to that model's behavior or other phenomenology about the model. The other is kind of changing the model's behavior. A classic interpretability technique for understanding would be, say, a sparse autoencoder used as kind of a purely observational thing, like what concepts seem present in this model. And steering vectors would be a classic control thing. And I think, notably, there are settings where sparse autoencoders seem like the best way to form an understanding of what's going on. And I think these aren't particularly contrived settings. It seems like there are a bunch of cases this is useful. Steering basically just does not beat fine-tuning unless it is a really weird special set. And I think this should not be that surprising. I think that basically all of machine learning is focused on the problem of how to influence the model's behavior and steer it and shove it in different directions and kind of give it data or a reward function or weird kind of loss penalties to kind of nudge it in the directions we want. It is not surgical, it is not fine-grained, but it does work shockingly well. And very few areas of machine learning are well-oriented around understanding things. I think that my current favorite definition of what Mech Interp even is interpretability is the study of kind of understanding things about the model, whether using the internals or purely black box. Mechanistic means things that refer to the internals, and the intersection is understanding the model using its internals, which actually has been like a reasonably fruitful direction, by being kind of surprised by just how much we can learn with black box approaches to understanding, like reading the chain of thought or talking to the model. But by and large, I think that we should be leaning into our comparative advantage in most situations where you want to do some form of control. I think that fine-tuning or some other technique will probably work fine, or even just prompting. And if you want to understand things, you have like a much more limited toolkit. I think that, let's see. I think that there are like some exceptions to this, but these largely look like exceptions where it's really hard to solve it with normal ML methods. In particular, things where kind of just get more data or just get different data doesn't really work. And basically, the only two things on this list that I would consider to be control would be suppressing eval awareness. This is difficult because, you know, the concern is that models will be good enough to tell if they are receiving a thing that is artificial. The way we make data is by making a thing that is artificial. So if the model is sufficiently competent, it should be extremely hard to make data to get around this. Admittedly, currently, in my opinion, people are trying extremely not hard to make things like alignment evaluations and traps for the model that are realistic, and they are often kind of contrived bullshit. Like they'll have a company called Tech Corp or something, where you don't have to be AGI to see that might be slightly sus. But yeah, so I think this is like one exception where I think data is like particularly hard, and I think the other is I think there are some situations where you'll want to kind of train a model, and it will be hard to get data to achieve exactly what you want. I mean, in some sense, if that wasn't the case, we wouldn't have an alignment problem. We would just get the data to make it aligned and then do it, and life would be good. Sadly, we do not currently live in a world quite that convenient. And yeah, so I think that studying kind of how you can achieve more fine-grained control here seems pretty important. But all right, that is my rant about why I do not think that controlling things is actually that big a deal. And I think people often have some kind of implicit belief that because you have used interpretability to understand something, that means you can now use interpretability to fix that thing. E.g., you found the biology direction, so now you can delete it, and you have achieved unlearning. And people may have noticed that we have not solved unlearning. And fundamentally, I think this is downstream of maybe a different underlying belief I have about interpretability, which is that interpretability can find real insights, but it is neither precise nor complete. We can do things like say, these seem to be the SAE latents that are important on this problem, or by reading the model's chain of thought, I have the following hypotheses about like roughly what's happening in it. These are actually quite useful things to do. They often tell you things that are true, but you cannot be confident they have told you everything, and they typically haven't. And with techniques like an SAE that are kind of trying to make precise mechanistic statements, like this is the direction for dogs or something, that is not very precise. Even if you have data, it is often not very precise. There's like spurious correlates, or just like noise, or things aren't represented exactly where you think they were because of cross-layer superposition and like random bullshit like that. And understanding does not need to be precise, but control often has a higher bar for precision. But also, if you understand a thing, then that can motivate ways to solve it that do not look like kind of directly editing the things you found with interpretability. I can use an X-ray to diagnose what happened to my leg and then fix it with a thing that does not shine more X-rays at the leg. And no one seems to complain about radiologists. All right, end rant. A lot of people seem to have this belief that interpretability, if it can't control things, is useless. And I'm just like, what? No, what? Arya?
Just a question on like control.
Mhm.
For me, one of the things I saw when I saw Golden Gate Claude was it would feel hard to get to something that was that, I don't know, Golden Gate Claude by fine-tuning. Do you think this is the case? Like, it felt to me that, okay, this was one of the times that through interpretability, we managed to actually make something that we might not have gotten to that point with just standard like fine-tuning in terms of its personality and everything like that. But maybe I'm wrong on that.
I mean, maybe. To my knowledge, no one's really studied this properly. I definitely think it could have been achieved with a steering vector rather than an SAE. I can believe that a system prompt would not have produced the same kind of insanity. I personally predict that if you fine-tuned on Golden Gate Claude transcripts, you would get pretty similar results. Obviously, having the transcripts is like in some sense cheating, but I feel like you could probably have made synthetic versions of those transcripts, and that might also work. And I think it was like unexpected. Like I don't think anyone expected. I think Anthropic was very surprised by how viral that thing went. I don't think they were expecting to get a thing quite that level of delightfully deranged. And I think that interpretability is a tool for discovering things I'm super on board with. And if you want to call, I mean, in a sense, I would consider it understanding to observe that it is possible to induce this behavior in the model. And if it was then actually really hard to get the right kind of data, I would take that as like pretty good evidence that maybe this is a thing where internals are winning. But there's like a lot of ifs in there. And also, yeah. Yeah, maybe I'm not trying to argue the strong position that there are like no instances where trying to do control with interpretability is reasonable. I may be trying to argue I basically haven't really observed instances where it seemed where there wasn't a good reason that other methods were failing, where it made sense to use interpretability. Maybe one other category of things that I think could make sense as interpretability for control is conditional steering. Basically, you've got like a probe, you've got a steering vector, you only add to the steering vector if the probe fires, maybe with coefficients proportional to the projection onto the probe. There was a nice paper from Bruce Lee, one of the former trainee scholars on this. And I think that, actually, yeah, does anyone have any guesses for why I think conditional steering might be able to achieve things that are quite difficult with other methods?
Maybe it's a matter of precision.
Say more.
So you don't always need to steer the model towards something using the latent, and thus you use a probe to maybe tell you when to steer and when to not.
Yeah, pretty much. The way I think about it is every time you have a technique that only matters some fraction of the time, you're kind of trading off the quality of your technique with the side effects every time it's not supposed to matter. And if you can have a good classifier that tells it when to fire, this is great, because there are zero side effects when it does not fire. Obviously, you need a classifier to be good, but I think there are a fair amount of things, but like it wouldn't be that hard. Yeah. That seems like a area of applied interpretability that I think kind of could have some mundane utility. And another thing which I think seems probably pretty useful, but I haven't seen used, is conditional LoRa's. Or like rather than applying a steering vector, you apply a LoRa. Seems like this should substantially lower the blast radius of some form of specialized fine-tuning. Seems like this would be quite easy to implement. I have not seen it done, not really sure why. I might have just missed a paper. But yeah, I think that by and large, I would put this kind of thing in the category of, I think it can be useful practice to try doing real-world useful things with interpretability. And these seem like helpful such things, but I don't see like a super clear path for using them like more directly AGA safety relevant things. So I'm not that excited about kind of iteration on those, unless it is using them as a tool in some intrinsically interesting task. But yeah, all right. Do I have any other categories of things that I think are interesting? I think that, I mean, yeah, one just general belief I have is your research is false until proven otherwise, and there are many, many, many ways to trick yourself. And what is my source of truth is a crucial question to ask yourself. All right. And I think that, oh yeah, maybe some other underlying beliefs. I'm more skeptical of our ability to predict which areas of interpretability matter or are most promising. And I think this means that the field should be kind of more diversified and just trying more new and different things. It's one of the reasons I am particularly excited for people to propose kind of interesting new ideas for sprints on mini projects. Though also most new ideas suck, so I do have a high bar. I think that, yeah. But yeah, I think this is probably an update I made in significant part because of being very excited about SAEs, and then the whole field being very excited about SAEs, and then concluding that this was misallocation of effort. But I maybe also just feel like things are changing a lot. There's like a lot of interesting new opportunities. We have actually good models. We have reasoning models. So many like things are different. And I think that when things are changing rapidly and the field ultimately is not that big, even if it has grown quite a bit, you should expect there to be a lot of low-hanging fruit and a lot of unexplored frontiers. And yeah, maybe some other takes that I have. I mean, a theme you have probably noticed is I am trying to be pretty pragmatic. I think that I just want to do the things that work. I think I used to have a bunch of inclinations towards, say, being massively biased towards using internals wherever possible, and thinking that black box methods were unreliable. I now think all methods are unreliable, and we've got to deal with it. And this means that figuring out when black box techniques have like an acceptable amount of unreliability, fine. And yeah, another one is interpretability can often best assist safety by augmenting other things. We're not going to solve the problem ourselves. So trying to make this more concrete, I think that if you can suppress the model's awareness that it's being evaluated, the entire field of evaluating models now is slightly less fucked. This seems great. But ultimately, they are doing like 95% of the work, and it's just like some interpretability researchers patched a thing that would have broken everything. I feel like, kind of zooming out, a lot of what makes me excited about interpretability is less specific instances of research results or specific research directions, and more, I think there's a bunch of things you can do if you try hard to understand what's going on and or mess around with the internals of the model. I feel like these are just like rich affordances that make many things possible that are fairly neglected and underexplored. There should be a bunch of things here that are useful. I don't necessarily know what these things are. I have a bunch of guesses. I'll talk through those guesses, but that's kind of how I think about it. And I think that one implication of that is there probably should be ways to take other methods that are mostly working and make them work better. I mean, potential other ones would be kind of helping alignment techniques, helping alignment researchers kind of red team the models they think might be safe and better uncover what's going wrong and why, and how this can feed back into how they should update their training methods, etc. All right, that was a lot of very abstract rambling. Your challenge for the next minute is to write in the chat the claim you most disagreed with in there. Saying I agree with everything will be penalized. Well, ideally, the claim and like some amount of pushback of like why.
Could you scroll up maybe and like make it smaller so we can see all the claims?
Sure. that better? Oh yeah, I should also add downstream tasks are great and my favorite source of truth. All right. Thanks all for the hot takes. I think I'll skip over the ones I intend to give a much more detailed answer to later on in the talk. Yeah. Let's see. I'd be curious to hear more from Elle on what you meant by understanding over control is at odds with pragmatism.
Oh, well, I guess sometimes like you can control things, but you don't know why. But if you have like a good downstream task, you can see that this like I'm thinking about your example of like using some probe to then modify the behavior by turning on like a LoRa fine tune or something. Like maybe you don't really like it's not clear to me that that's understanding, but that is like useful control. And it feels like maybe I'm overly strongly interpreting your point here about focusing on understanding things, but it seems like sometimes you know, like you can't understand it. You can just kind of get used to the fact that it works. Sort of situations can exist all the time.
Yeah. Cool. All right. Great pushback. All right. So I think I mostly disagree. But these are great questions for unpacking nuance. So I want to do the things that are most useful and valuable, especially in the context of kind of other things people are doing, other approaches to making models safer, etc. And my core argument is not that interpretability can't be useful for controlling things. It's that I don't think this is our comparative advantage. I think that you can do a lot of useful things with understanding. You can do a bunch of useful things with control. And I just think that there's much less counterfactual value add on control apart from a few specific niche cases that I was trying to outline. And I put conditional steering and conditional LoRa's kind of in that category of like, I think most methods for changing a model don't have the ability to kind of be conditional. Like, that's not really a thing models do. It's more like a thing you have to do with scaffolding. And this is just a way to scaffold things in a useful way. But I mean, you could also have like a conditional system prompt. Like that'd be completely fine too. So, I think that, so to me, pragmatism is about once you have decided what you are trying to do, just do it. With whatever is going to work, with some allowance for arguments, for e.g., well, this technique works now but isn't scalable. This other technique's way more scalable, so I should like practice using that one or something. But the way I think about this kind of thing is more like kind of like a subsidy. Like, well, there's this technique, and it costs a certain amount to use in terms of like effort and compute, and it has a certain amount of value. Let's just pretend the cost is a bit lower than it actually is, and then decide what the best technique to use is. But if it's like vastly less practical than some more pragmatic technique, or like works much worse, like why use it? And you know, it's very easy for there to be a technique that will take like at least one researcher month of effort to do, and then a stupid thing like prompting that you can do in half an hour. And yeah, but I'm kind of, my understanding versus control point is more about choosing the problems you try to work on, where like, why did the model do this is a valid problem, in my opinion. And the question is, what's the best way to solve this problem? Which maybe kind of also gets on to a point below from Simon on kind of, it should be about providing understanding, not about beating baselines. To me, beating baselines is more than just about, it's more than, say, you have a benchmark like MMLU and it has a number and you're seeing if you can beat that number. It's about, is there a simple, more standard approach to solve this problem that would do at least as well as your approach? And so, you know, there's totally baselines for providing understanding. A classic is a human looks at it and guesses, or a language model looks at it and guesses 100 times, and you do majority votes. Those are baselines. I don't claim they're good baselines, but if you're not beating them, it's kind of embarrassing. Am I correctly understanding the objection, Simon?
You mean mine?
Yep.
Yeah, exactly. I mean, kind of, maybe what I mean is like, I think it's often like beating baselines often also involves like using tricks. And this somewhat goes also into that you trick yourself. Because, I mean, if you try to get lower numbers, say on some benchmark, then it's what people do in practice. Like they take all the shortcuts there are and even do unsound things. And I think this is something that we should avoid.
Yep.
doing.
Yeah, totally on board with that. Also totally on board with what you said in the chat about being simple. I feel like a common trap is people come up with like a really clever method and they feel really excited about it. And then it turns out that if you delete half the details, it actually works just as well and is like 3x easier to implement. And this is an extremely common mistake in junior Interp researchers, or, well, I think just researchers in general. Don't let this be you. Definitely a question I will ask in a sprint interview if you have a complicated technique is, what happens if you don't do that complicated bit or that complicated bit? The kind of jargon for this is like ablation studies. If you have a technique, you want to try getting rid of each detail one at a time and seeing what happens. Another thing that I kind of learned, especially from adventures, trying to figure out how practical getting DeepMind to use interpretability stuff in production is that the simpler the thing, the better. It's just like way more complicated to do anything in production than it is in research. And every additional bit of complexity often means you have new stakeholders who need to sign off on the thing. And even getting approval for something like probes would be like a nightmare, because that's changing the implementation of the model as it is served. Now the people who control the serving stack need to like agree with this and like, while if you just have an autorator, which is like an LLM kind of reading the outputs of the first LLM and doing something, you need to talk to far fewer people because text is a exposed thing that passes between different bits of the model, and thus it's like a fairly reasonable thing to work with, and people complain much less. So, you know, if you want to run a language model every time someone runs ChatGPT or something, that's like pretty damn expensive. So you still have issues. But yeah, I think, so yeah, simplicity is both kind of about the amount of details and the implementation complexity, but it's also about kind of how much of the model training and deploying pipeline would need to be changed to use your technique. Where, you know, evaluating the model, that's easy. You can just do that unilaterally. And that might give you useful insights. So like, that's a really convenient kind of thing. While changing the model architecture to reduce placementicity is like completely fucking doomed, because everyone has a stake in this. Because you're just changing the like underlying model from pre-training onwards. And unless you've got a good reason, it's a pretty big lift. God forbid you make performance worse. And yeah, I think another manifestation for pragmatism is do the things that will actually have real world impact. where, I'm not saying you need to be like purely myopic. It's fine to pursue a thing and say, well, if this does work, it'll be such a big deal that it'll be possible to make big things like this happen. And if it doesn't work, who cares? But I think it is a useful thing to bear in mind. And definitely a thing that skews what I'm excited about. And yeah, I think maybe another thing you said that I also agree a lot with is, at least I would frame it as, always know what your goal actually is, and when what you're studying is a proxy for that goal or your actual goal. And be pragmatic about your actual goal, not about your proxy. Like, if you're studying MMLU because you want to make a better model, you can make your MMLU score much better by training on the test set. That's obviously stupid. I think there are many things that are basically as stupid as that, but just a little bit less obvious. Because people lose sight of like what is a proxy and what is the actual goal. All right. The other things. All right. Ooh, a bunch more pushback from chat. Great. So yeah, I guess I'll talk more about black box methods later. Yeah, so okay, so Gerson raises an interesting point, which, if I'm understanding correctly, is basically, if you have insight into the model, you should be able to better control things. To which my answer is, if that's true, why can't I use an X-ray to fix my leg? I feel like understanding can motivate fixes, but the fixes do not need to look remotely like interpretability. If we can produce insights that, like, people who are post-training the model use to post-train a more aligned model, like, that's great. I am super, super into that kind of thing. But it's just not obvious to me at all why you need to, yeah, just like, the solution and the diagnostic tool do not need to have the same type signature, basically. And I think that the precision required for fixing a thing is often quite a bit higher than the precision required for diagnosing a thing. I don't know, curious if that, like, accurately addresses the claim you're trying to make?
Yeah, that argument makes a lot of sense. I guess I'm trying to think of an example where, like, somehow interpretability would, using interpretability to control would be advantageous, but I guess it's not coming to mind. We mentioned like the Claude Golden Gate case earlier, but
yeah, and like, again, I'm not saying it's literally never a good idea. I just think it should be a fairly small fraction of the fields, and you should have a kind of good, the way I think about it, I would like people to just, as a prior, say that a control-related project should not be something they're doing. And it's fine to overcome this prior, but you need like an argument for why this overcomes the general prior that this is not the comparative advantage of the term.
I guess...
sorry, go ahead.
Sorry. Yeah, I guess like one example I want to think through, like, let's assume sparse autoencoders were, I guess, less error prone and whatnot, right? To the point where, like, you could identify features and then easily steer them, right, and get the results you're expecting. That would be, not saying that that's like practical as of today, but like that would be a case where, like, using interpretability would help with control. Like, maybe
Yes.
if the methods, if interpretability was in a better state to control, then like you revisit this question.
I think that is related to this claim. I don't really see SAEs getting that good.
Yeah.
More importantly, I think that if you want precision, you should obviously be using supervised methods because data is useful. And I think that even with supervised methods, we still are not great. at doing surgical interventions with Interp. I mean, you might want to combine the supervised and unsupervised method, like use the SAE to get a initialized steering vector, and then you fine tune it a bit with data, or you're trying to lower side effects or something like that. But
yeah, and even in that case, it's like the interpretability part is for understanding and then using the, I guess, black box methods for controlling.
Yeah. And yeah, so yeah, I'm like, yeah, I agree that there are exceptions to this. I just think that you have to try to come up with the exceptions. And I think that it's very easy. I don't know, I think there's like a bunch of steering vector papers that I basically just don't think should have been written because they don't have a good story for why this would be better than fine-tuning. I will flag, I think that downstream tasks about controlling things are a super reasonable thing. I think that if you want to show that you found the Golden Gate bridge vector, showing that you can make Golden Gate Claude is a fucking excellent demonstration. But the goal was not to make Golden Gate Claude. The goal was to find the Golden Gate bridge vector, and this was your source of truth, which is another common confusion when I give this rant. But yeah, all right. So were there other things in the chat? Yeah, so I guess Aria raises the objection, if I understand it correctly, of it seems important to be involved in the kind of application product level, learn from what needs to be controlled, e.g. user experience, and kind of practice solving these. And I guess to which my answer is sure. And I predict the way we should solve them is by helping diagnose the issues and then telling the post-training team what the issues are and how they might go about fixing them and why their existing methods aren't fixing them. And I think that's a perfectly reasonable kind of project that I think could be fairly fruitful. But yeah, I think plays more to our comparative advantage.
Is this something you know that's being done in labs today? Like, for example, when I talked to Claude Code, it recently started being able to ask me questions when it feels confused. It's like, oh, do you mean this repository or whatever? So is this something that the Interp team is working with the model team on to be like, oh, like we can help induce this behavior. You should probably modify this part of the model, something like that?
So yeah, so obviously I can't really comment on DeepMind. If I were to wildly speculate about other companies, I would guess this probably isn't happening. But if nothing else, this would be because those teams, the like interpretability teams of both OpenAI and Anthropic are like very AGI safety focused, and thus I would guess they are more likely to be doing things like working with the evaluations team. And as I'll talk about in a bit, the Anthropic Interp team recently put out a bunch of cool work about having done this. But yeah, I think trying to figure out what it would look like to get interpretability things into production at DeepMind and kind of someone exploring this process was very educational for me about like, what are the actual constraints here? What kinds of methods could be deployed? What kinds of things are a clusterfuck you shouldn't bother with? That kind of thing. But yeah, so, and yeah, I guess Lewis says interpretability does not have to be imprecise, to which my answer is prove me wrong. Hasn't worked yet, in my opinion. Sorry, I can't hear you. Nope. You're not muted, so I'm not entirely sure what's happening.
I also can't hear him.
Oh, sound happened.
Maybe there?
Yep. Now it works.
Okay. So like currently it's imprecise because of the unsupervised tooling and techniques, and also because of the nature of wanting to overview the modeling from a higher perspective and not from the weights and activations. But I think that there could be cases where we could get high levels of precision. Maybe not 100% because of the nature of the architecture of transformers, but I think that mechanistic interpretability, not interpretability as a whole, but mechanistic, should try to reduce the imprecision of current methods. That's the whole thing about mechanistic, no? Like wanting to not give bad approximations, but good ones. And a good approximation should not be imprecise, but not perfect.
Yeah,
I'm
so
not saying that it's possible because challenge accepted. But
yeah. I mean, I think the is this possible and or is this remotely practical is like a pretty important crux for me here. I guess maybe it's not super obvious to me that there's like that many valuable things I could do if I had precision that I cannot currently do, or like could not do in other ways. But that's a speculative claim that I think is very plausible and wrong about. I broadly think that, let's see. So I think that one thing that matters a lot here is what level of imprecision is acceptable. Because like, if we were doing a bunch of things with current pools, and we clearly were suffering from the imprecision, and every bit of progress reducing the precision, making it more precise, would make our like important use cases better. It's pretty good. I like that. That's like a pretty good reason that you might want to do this kind of thing. But on the other hand, you have things that are more like, you have things that are more like, why? Yeah, I just don't think there are things that we can currently do that would be like clearly better if it was moderately less imprecise. I could believe that there are things you could do if it was like dramatically less imprecise, but this means that it's harder to justify incremental work on this unless you have reason to believe that you're going to be able over time to have enough incremental work to have a big qualitative jump to the point that matters. And like, you know, this is a forecasting question. There is not some like objective answer we can know now, but like my best guess is it's the wrong allocation of resources. But yeah, if you want to prove me wrong, that'd be great.
and what kind of applications or situations could we like tackle if we have more precision in certain techniques? Or
great question. I mean, generally things around like model editing and like very surgical removal of things. Like it'd be quite nice if we were able to do this. You know, it seems like maybe it's very hard to make models that are not evaluation aware, but not very hard to just remove the concept of evaluation awareness from the model. And maybe, yeah, or like, you know, things like the ability to be deceptive, things like this. Like, that'd be pretty epic. Honestly, it's plausible to me that steering is a crude enough tool to basically work there anyway. I'm not really sure. It seems to work reasonably well on evaluation awareness, but all right. I think that is, yeah, probably long enough on that.